3 years, robot competitors and their humans have taken to the field at Worcester Polytechnic Institute to show us what they're made of. And NASA 360 has been here for it all. While pushing technology to the limit, we've witnessed the highs and lows of NASA's Sample Return Robot Centennial Challenge. Robots have lost their cool, roved where they shouldn't have, given new meaning to the word tree hugger, and even tried to escape the playing field. But every setback pushes teams to create new and innovative solutions. So, what's the goal? In Level 1, autonomous robots operating free of humans need to find a sample and bring it home in 30 minutes or less. Do it, and they win $5,000 and the right to compete in Level 2. In Level 2, the stakes are much higher, about $1.5 million higher. In prior years, 2 teams have already earned the right to compete in Level 2. This year, 14 additional teams will vie for a spot to join them as they compete for $1.5 million. Want to know what makes these robots tick? NASA 360's back, and we're going to reveal the technologies that have given a few of these robots the inside track to Level 2. I'm on the viewing platform where later today our teams will get a front row seat as they watch their Rovers go for the gold. But before the competition gets rolling, let's see how it all goes down. The Sample Return Robot Centennial Challenge is just one challenge in a larger platform of centennial challenges for NASA. What's the overall goal for these challenges?
The overall goal of the NASA Centennial Challenges is to advance technologies for NASA, so maybe in the future we can infuse them in our projects and programs, and to advance the technologies for the nation.
So we put up a pretty broad spectrum of competitions that we run through the Centennial Challenges program. So we'll be doing anything from autonomous robots to propulsion and communication systems for CubeSats. We've done electric airplanes, we've done better astronaut gloves, vertical takeoff and landing vehicles.
The goal of the Centennial Challenges is to help advance the technology in a variety of areas and also provide opportunities for those new technologies to turn into businesses for the teams that develop them as part of a challenge.
Having a robot be able to navigate, avoid obstacles, collect samples without a navigation system such as GPS or magnetic compass would benefit NASA in terms of planetary missions, but also benefit industry for infusion into Earth-based technologies.
Many of our competitions we've seen our competitors go off to great commercial success post-competition. So no different with this challenge. A lot of our competitors are already talking ideas with each other for where could this technology be applied. Could it be applied in the service industry, for delivery of goods, or for assistance? You know, there's a lot of different areas that we could be applying these autonomous robots to.
That type of model where they actually take the technology they developed specifically for this challenge, but then have a business idea or an idea that where they can then infuse it into a product or even a service. That is the perfect scenario that we look at for our program.
So even if somebody doesn't win the competition, there's always potential for them to succeed commercially themselves with the technology they develop in this challenge. So the purpose of the Sample Return Robot Challenge is to help build that foundational technology support for autonomous robotics.
Competitors are asked to develop technology that enables the robot to navigate a terrain, avoid obstacles, and find, in Level 1 in particular, a cache sample.
So this is the combination of mechanical systems and electrical systems and software, but putting them all together and making them work is very challenging.
Spectrum of technologies all being infused together into one system, and that's what we're doing here at the Sample Return Robot Challenge.
If a competitor gets to Level 2, the first thing they need to do is go get the same cache sample that they got in Level 1. Beyond that, there's objects scattered, sprinkled throughout this park.
In order to win any money and to show that they're successful at Level 2, they have to bring back at least 2 samples. One of them is the pre-cache sample from Level 1, and then at least one other sample on the course.
You have to remember, this competition field is the size of about 1.5 football fields in a dog-leg pattern or shape. So it's a huge area for these robots to have to roam around to go find the samples, detect them, pick them up, and then bring them all back to that single starting point.
But before we can get to Level 2, we have to get through Level 1. 10 teams made it to the field to compete for Level 1's $5,000 prize. Some of the Rovers didn't make it off the starting platform. Others made a break for the sample, and one overeager rover even fell head over heels, well, head over wheels, looking for the sample. Now it's time for the main event as two teams compete for $1.5 million. And it all starts right here on this platform. First up, Team Survey. Team Survey's been competing in the Sample Return Robot Centennial Challenge since its inception in 2012. And until today has been the only team to compete for Level 2's $1.5 million prize. And with 2 hours on the clock, the rover is off.
So we decided that the best thing to do would be to make a 90-degree turn off the platform and start exploring the park from there and look at anything that it thinks is a sample along the way. So right now it's exercising all of its sample detection, which I think is, that's really, really difficult to determine.
The rover continues to explore its surroundings.
It takes high-resolution pictures of the area. It uses that information. It analyzes those images and determines if there are samples in the image. And there's a whole chain of stuff that happens after that. It passes it down to the computers, and then it sends the robot after it. And so Steve is getting to hear it say all the confusing things it's saying. It's probably saying sample detected.
Sample detected.
Pursuing.
Pursuing.
And then it's saying
exiting pursuit.
What if it's not a sample?
So the rover found the pre-cache sample, and although this is worth no money, it is a requirement in the Level 2 competition.
Tell me a little bit about the technology that you're using and, what applications it has here, and maybe what applications you think they could have beyond this challenge and just in the future.
A lot of the technology in the robot that is different and important is all in the software. The motors, the actuators, the cameras, and everything is pretty normal stuff. Like there's nothing special about it. We haven't designed any new physical stuff. It's all in the software. And Zach's been working on a lot of algorithms for detecting interesting objects. Salient is the nerdy computer vision term. Objects in the camera's field of view, and that's going to be the important technology that comes out of this is object detection in cameras and navigation for robots, that kind of stuff.
Although Team Survey was able to identify and retrieve the required pre-cache sample, their rover was unable to pick up any other sample, missing their shot at the big prize.
Unfortunately for Team Survey, one of the areas that they spent quite a bit of time in has a sample, and the robot had actually locked onto it, but it got a little confused when it got right up on it. That's still really impressive that they were able to
The fact that they were able to
sample.
detect it at all, because they don't even know what shape it is, they don't know what pattern, but the fact that it saw it and knew it was a sample, it circled around it, is a really impressive feat on its own. Yeah, it's tough. It's a huge problem, and there's so many little things that you have to know.
Yeah. Well, I for one don't view this as a failed test by any means. I hope you all don't either.
No, the robot is not on fire.
Well,
it's not in the lake. So there's a lot of things that can be
No one was injured.
Yeah.
Next up, the West Virginia Mountaineers. Last year was the Mountaineers' first go at the Sample Return Robot Centennial Challenge, and they easily qualified to compete in this year's Level 2. And they're off. The rover's headed towards the pre-cache sample, proving that it can still complete the Level 1 task. They're close, a few more feet, and they've got it. Now all they need to do is bring it home. They've managed to pick up and return the pre-cache sample, so every item located and returned after this is worth cold hard cash.
So right now it's just scouring the field, going through a huge list of travel waypoints, and it's just searching at every one of those waypoints and see what it finds.
At each search waypoint, it'll stop, rotate the camera, and take 9 pictures. And after it takes each image, it processes the image to see if it can detect a sample. We've got the LiDAR on there. It's the laser scanner that's nodding up and down, and it can create a 3D point cloud and tell us if it sees an obstacle. And it also allows us to do the precision drop-off.
So why do they do a pre-cache sample for Level 2?
That's a good question. I guess the idea is that on a mission, there's a sample that you definitely want to bring back, and then you also want to be able to bring back, some interesting things that you see. So you definitely get the pre-cache, and then you get some extras if you can. If you've got, oh, it's trying to pick something up.
Now all they need to do is bring it to home base, and they're up $100,000. Just a few more feet, a few more inches, and they did it. The Mountaineers have just secured $100,000.
West Virginia University just had an awesome run. They caught samples and it earned them $100,000 in prize money. And perhaps coolest of all, the team has decided to donate the prize money to their school to set up a robotics scholarship.
It's good to see that all our hard work finally paid off. We're pretty happy with the run. We had a couple of chances at some of the hard samples that it looks like we missed, but overall I think we're all pretty pleased.
NASA may have awarded $100,000 today, but what's been gained is worth so much more than that. Sample return competitors have spent 4 years designing, building, and bringing their rovers to life. In doing so, they've progressed not only the field of robotics, but forged new innovations and advancements in mechanical engineering, software engineering, electrical engineering, all while giving NASA a fresh perspective on an out-of-this-world challenge. I'm Molly McKinney, and this is NASA 360.